Section 4.6 is on the quadratic formula and the discriminant. The quadratic formula, you should remember this from Algebra 1. If ax squared plus bx plus c equals 0, then, listen closely, I'm only going to sing it once, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you remember that from Algebra 1? Now we're going to use it and come up with some more interesting answers than we did back in Algebra 1. So, let's use the quadratic formula to solve each quadratic equation. First thing that we really want to do is find what a, b, and c are. A is the coefficient of x squared, b is the coefficient of x, and c is the constant all by itself. And we're just going to plug those into the quadratic formula and then simplify it. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. For these first couple examples, I'm going to show every step. Sometimes you can do some of this in your head, especially if a is 1, it gets a little bit easier. So x equals negative 6 plus or minus the square root of 36. Now we have, I like to think of this as negative 4 times 1 times negative 16, which comes up to 64, positive 64, all over 2. Or x equals negative 6 plus or minus the square root of 100 over 2. Or x equals negative 6 plus or minus 10 over 2. I want actual numbers, so I'm going to actually write each one of those over here. X equals negative 6 plus 10 over 2, and x equals negative 6 minus 10 over 2, or 4 over 2, or x equals 2 for one of my solutions, negative 16 over 2, or x equals negative 8. So one of the possible results you can get when you use the quadratic formula is to have two real rational numbers. Okay, let's try it with this one. You might need a calculator. So, x equals, let's identify a, b, and c. A is 1, b is 34, and c is 289. So x equals negative b plus or minus the square root of b squared minus 4. Actually, that looks more like a 342b squared minus 4 times a times c all over 2a. Or x equals negative 34 plus or minus 34 squared is 1,156, and 4 times 289 is also 1,156, all over 2. It's going to give me x equals negative 34 plus or minus the square root of 0 over 2, which is the same thing as negative 34 over 2, or x is equal to negative 17. In this case, I have only one solution. When I did the square root, the stuff underneath the square root, it ended up being 0, so I only had one answer. Remember from a couple sections ago when we were graphing these, if we were to graph the related function to this equation, it would end up touching the x-axis only at one point, where x is equal to negative 17. Here's another example. Let's try this one. A is equal to 3, b is equal to 5, and c is equal to 1. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Or x equals negative 5 plus or minus the square root of 25 minus 12 all over 6. X equals negative 5 plus or minus the square root of 13 over 6. Well, I can't simplify the square root of 13. There isn't anything to factor out and divide, so I'm just going to leave my answer like that. I could plug it into the calculator and get a decimal approximation, but I really like numbers that look like that a lot better. That's exact. So x equals negative 5 plus or minus the square root of 13 all over 6. And number 4 here. A is equal to 3, B is equal to 5, C is equal to 4, x equals negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 3 times c, all over 2a. X equals negative 5 plus or minus the square root of 25 minus, let's see, what does that come out to? 48 all over 6. Or x equals negative 5 plus or minus the square root of negative 23 all over 6. So here we have a square root of a negative number again. So 23 cannot be simplified. So we'll write our final answer as x equals negative 5 plus or minus. Let's kind of pull out that square root of negative 1. Make that an I out front. Square root of 23 all over 6. So in this case, we actually have an imaginary answer. Our answer is a complex number because we had the square root of a negative 23. So let's take a look at what some of all of this means. One thing we're going to focus on is something called the discriminant, and that is b squared minus 4ac. That is the stuff that's underneath the radical sign. So b squared minus 4ac. If we figure out the value of just the discriminant, instead of going through the whole quadratic formula, just what is b squared minus 4ac equal to, that value can tell you the number and types of roots of a quadratic equation. So, for example, if the discriminant is greater than 0, if it's a positive number, and it's a perfect square. So if b squared minus 4ac is greater than 0, and it's a perfect square, we're going to have 2 real rational roots. Now this is what we saw in our first example up here. Notice the stuff underneath the radical, the b squared minus 4ac, ended up being 100. That's a perfect square. So we had 2 real rational roots. If b squared minus 4ac is positive, greater than 0, and is not a perfect square, then you're going to have 2 real irrational roots. In other words, it's not going to be nice numbers right here. It's going to be that case where it falls between 2 integers. And I believe that was our second example here. Oh no, did we have one like that? Oh, we did. This one here, it was like that. So notice we have the stuff underneath the radical is not a perfect square. 13 is not a perfect square. So I have 2 real roots, because that's not a negative number, but they're not nice numbers. They're not integers. If b squared minus 4ac is equal to 0, then we're going to have 1 real rational root. And the graph's going to look like this. It's going to touch it in just one place. And I believe that was our second example. Yeah, notice here underneath the radical I had 1156 minus 1156. I had the square root of 0. So b squared minus 4ac was equal to 0. So I just had one answer, one solution. And the last case, if b squared minus 4ac is less than 0, in other words, if the stuff under the radical is a negative number, I will have 2 complex roots. And the graph of that looks like this, or it could be going upside down, but it will never cross the x-axis. And that was my last example here, where b squared minus 4ac was equal to a negative 23. So I have two complex roots. So, for each quadratic equation, find the value of the discriminant, and then describe the number and type of roots, then find the exact solutions using the quadratic formula. Okay, so we need to find first just the value of the discriminant. I'm going to go ahead and identify my a, b, and c. So I think that makes it a little bit easier. So, if I'm finding just b squared minus 4ac, so that's going to be 8 squared minus 4 times negative 5 times negative 1. That's going to give me 64 minus 20, where the value of the discriminant is 44. Now I need to use that number to describe the number and type of roots. So 44 is greater than 0, but it is not a perfect square. My discriminant is a positive number, but it's not a perfect square. 44 is not a perfect square. So I have two real irrational roots. Okay, so the value of the discriminant told me that, gave me that information. Now I'm going to finish solving using the quadratic formula. So x equals negative b plus or minus. Now I already did b squared minus 4ac. That's 44. All over 2a, I can do that in my head. Negative 10. Let's simplify that. Square root of 44 is 4 and 11. The 4 will become a 2 out front. Square root of 11 over negative 10. I can actually factor a negative 2 out of everything. So that'll give me 4 plus or minus the square root of 11 over negative 10. And canceling, I'll have 4 plus or minus the square root of 11 over 5. The negative 2 and the negative 10 cancel. So there's my solution to that quadratic equation. Let's take a look at another example here. So a is 2, b is negative 6, c is 9. Let's find the value of the discriminant. B squared minus 4ac, or negative 6 squared minus 4 times 2 times 9 is going to give me 36 minus 72, which is a negative 36. So the value of the discriminant is negative 36. Because that number, I'm going to go back to my chart here, because the discriminant is less than 0, it's a negative number, I'm going to have two complex roots. And now to go on and continue solving it. X is equal to negative b, so the opposite of negative 6 is positive 6, plus or minus the square root of negative 36. Remember, that's my b squared minus 4ac. I already did that. All over 2 times a, which is 4. Let's clean that up a little bit. So that's going to be 6 plus or minus. Square root of negative 36 is going to give me an I for the square root of negative 1. Square root of 36 is 6. So that simplifies to 6i over 4. All of those can be divided by 2. So my final answer is 3 plus or minus 3i over 4. Oh, sorry, 2. Or if you want to write it as a complex number that looks more like a complex number, with the real and the imaginary parts separate, you would do it like that. 3 halves plus or minus 3 halves I.